Yes, hope my screen is visible.
Yes, sir.
Yeah. So, as per discussion, we are going to think how we can implement doubly linked list, and after that, we are going to write the method how we can add node after a specific node. Okay, and I'm just explaining the logic, how this works, and also explaining how you can write this code. Okay, please ask questions when you have any doubt, because this is really needed to the way I'm able to write the code. You should also be in the position you can write the code when you know the logic. So let us, as usual, start one class. It's like a lovely linked list. Okay? And let us one write a subs like a node head node. Well, so first create a class node have a like a element like a integer data, and let's one is node your previous, and one is your node is next. Okay? Uh, and let's just create a constructor so that we can create the object. This is the simple class. Now you have a node and now two variable declared. So as usual, let us create a method first to create void add last. Okay. Mm, simply say add last. Mm, so this will receive some data part, and so let's start here. Mm, so you can say here just as usual whenever you receive any data, that means sure you want to create one new node. Okay. So node new node equal to node, and we have a data. What would be the next? I don't know. Next would be null. What is the previous? What is the previous? So as again discuss the logic. So where is yes, is my cursor. So as usual thing might be scenario ki whenever you are going to add no last. So let's get this scenario. This linked list is already available. Right? So this would be your head. This would be your tail. Excuse me. So whenever you second, you create a new node as usual. New node you created, and that you have to make a relationship. So whenever you say new node, the my previous would be always tail. Is it correct? And what should be the my next should be null. So I am saying ki our next should be null, previous should be always a tail, because whenever any linked list exists, that means ki tail always pointing to the last node. Yesterday there is a doubt in this course method with we have a how we are writing this previous and next, because this is the logically thing ki whenever any node and linked list create, I want to add last. Last means ki new node we created, and after that I say ki what would be my previous, what would be my next. The previous must be your tail, and last should be your null, because I don't know the which would be the next. So I here write ki our previous should be tail, and this is the data. So this is my node. What is my previous? Previous would be tail. What is the next? Null. And any doubt till now?
No, sir.
No, sir.
Another case. Whenever you are going to create linked list and you create this, and one scenario maybe linked list is not created previously. Then this means कि my head and tail are pointing to the null. There is no head, there is no node. Okay. So in this case, my new node would be the head node. Okay. Is it right? So we have to consider कि whenever we are going to add last data in the linked list, we have to check both scenarios. First scenario might be linked list exist, then our node should be last and previous would be the tail. Second case might be there is no linked list exist, then our my new node will become head and new node become a tail. In the both cases, whatever you creating a new node, that new node always become a tail. One thing also, existing linked list already created, but you create new node and make a relationship, and after that you can say new node would be your tail. Similarly, whenever you're creating your second scenario, there is no linked list exists, then you can say my new node is a head and this is also tail. In both cases, your new node is always going to the tail because you say कि this is the last node. So here you can say this is a tail equal to our new node. Whenever you anyone invoke this method, my new node created and new node become a last node because you say कि add last. And here you can simply say if you check if your head equal to null, that means the linked list not created. In this case, you can say what say कि our head equal to new node. Else, what happen if that's scenario? If head is not null, that means कि what you are going to do. Let's again think. First case you handle. If excuse me, head is null, then you can say कि this is my new node is the your head part. That's good thing. Second scenario, if head is not null, let's see some linked list is already created, and then you want to add this method. So you created a new node. Surely you need what is the previous? Previous by the tail. This is the tail, and now you can say this is the tail. This two lines say, and so head not equal to null. Surely head not null. Then you can say what? Here you what you can say कि whatever the my this is the whatever the my this is the tail. You have to make relationship with this tail part. Tail dot next would be this, right? Tail dot next would be this. Is it correct? Because our you want to not the first, second, third, tail would be the next here. So you have to make sure कि our whatever the existing tail next would be this one. So here simply say कि our tail dot next would be new node. But you have already tail change here, tail don't change here, tail change here. Okay. So this is the code. Yesterday, so here what we are doing? We are creating one new node, one new node, one new node. Anyone invoke this method, and you say कि what is the tail and what is the next? Next say next would be the null. Next would be null. Tail would be the my previous tail. Previous would be my tail. So whatever the tail existing, that would be my previous. This is the linkage you have already done here in this first line. First line you can make two link. This is your data part. What is my previous? Previous is the net. What is the my nest? Nest is the null. And here you again check head null, then this is my head. And if not, then whatever the tail, whatever the linked list already exist, exist, whatever the tail dot next, just link here. Means here your new node are going to link in a linked list. So this relationship are always linking whatever the new node creating at the last, because tail dot next equal to new node. In this method, any doubt?
Yes, sir.
So let's look the just so function. Okay, void so from head. Okay, so from head. So there is a simple just make a node temp equal to head start, and you say while until temp not equal to null, you can simply say s out whatever the temp dot data plus just print one space, and after that you can say temp equal to temp dot next, so that you are going to the previous, and after that just make s out, and here just print. So whenever you say this, let's create a linked list equal to new, and here say not add. Instead of just write one add method, instead of add, you can say like add method. Okay, just add, and just internally note add last. Okay, so here you can say add. Okay, and add say like a, and just so dot so. Let's create run it. So till now 6 is added. Just add another like a 9. Let another like a 10. 12. So our linked list work properly. There is no problem. Oh, okay. They are not working. What are doing? Only print 6. Why? Okay, this is the tail dot next. No head dot next. Sorry, temp dot next. Right? And you can also write one method check from tail. So from tail. Tail. Okay. So here he start from tail, and tail dot just check our previous link also working properly. So let's go and check we are able to maintain the previous link or not. Just tail. So here, so till now we are able to read from head to tail and tail to head. Let's add one more element so that at least 4 5 elements are available like this. Here today next method we are going to do, can we write some method like after a specific node I want to head or want to tell. So any places now you can add method. So the check, like one more method, we want us like add. I want to add after 12 or add after 9, right? This is the code. So first methods like void add after, and we can check one input data. Let's in the case of uh, data part, and second you have to new node, you want to new data you want to add. So next input your new data. So first things, whatever the you want to add after 9, let's assume. So you have to first find the your node where you want to add. So as you have to just write one method like get node uh, data, and you can say here this will return a node itself. And as usual, how to find the node? Just you make your while loop and just take one node variable temp equal to head. You can say temp not equal to, then you can say temp dot data is matched with the input data. If match, then return. If match, then return temp. Okay. If not match, then you can say temp equal to next temp. Just check the next. Let's put curly brace so it's clear what we are writing here. And uh, what happen if whole you iterate the list still not found and return a null. So first things you are doing to check you are able to found data or not. So just get me data whatever user want. Just check I am able to found data or not. Data dot node dot data. Let's check if we are able to found the node or not first. Let's invoke doubly link dot data. After let's say I want to 9, after I want to add 99. Okay, just you run. So at least we are able to found data 9 somehow, right? So now you are in a position you find the data next 9. I want to add after 9. So here the logic again. Just imagine. Where this is the, let's assume this is our example. In this case our 2, and next we have a like 12, next we have a 9. Okay, 9, and now we have a 6, and I want ki after add 99. The first things our logic, you create new node. Okay, 99. So previously what happened, they have a two link, one is the next and the previous, both link have each node. So here after 9 you should jump 99. So whatever this next variable, this should be point to here first things. And what this nest value exists, you can place is this nest, so that now this nest link to here. So this nest variable must be pointing to your new node, and but what is the next value must store is the new node next, so that they can pointing to this new node. Similarly, this is the next node, this is the previous node. So next node previously pointing to this 9, but now this next node must pointing to previously to this new node. So this node have a, what is the previous? This previous node would be the found node. So you have to maintain here change. First create a new node and decide what is my previous. Previous would be the found node, correct? What is my next node? Next node would be whatever the next of found node. Found node next is 6. The next should be 6. So whenever you're creating a new node, at that time you can make a two link. One what will be the previous and what would be my next. And after that, you have to maintain the this node previous and this node next. You have a three works you have to do. First, new node relationship. Second, your found node. And third, your what is the next node. Because from next, previously you are jumping to the here. Now, after this added node, your previous should jump to the here. Logic is clear. Let's write the code. Any doubt?
No, sir. No, sir.
So let's think. Now you know ki this is my found node, okay? Found node, correct? Found node. And just you create a node, new node for 99, uh, new node, and here you say next, previous, and your new node, new data. So here you think what would be the my next and what would be my previous. The previous would be the found node. Is it correct? Or what would be the next node? What was the next of this? What was the next of this node? Let's found the found next. NOD for found node next. Found node not next. In this case example, what would the our next node? Found next node of previous. So here what you did, you have already found node 9, right? And next node is the 6, right? Now you create a new node. Here you say link. Data is the data. What is the my previous? Previous would be the found node, right? This is the my previous. What is the my next node? Next node will be the 6. How to find the 6? Because this dot next is equal to 6, right? This is. Any doubt till? So
No,
you
sir.
have to create the new node and you make a link. What is the my previous? Previous is the found node. What would be the next? Next node would be the what is the next of 9? Next of 9 is 6. Now my next would be the 6. So now you have a think relationship. Previously from here you jump to the here. So now you have to change this. Whatever the next this have, they pointing to the this one, right? And similarly, from here previously we are jumping to the 9. Now we have to change this next should be this new. Now we are going to make this link. Whatever the existing found node and whatever the next node, they have a relationship previously 9 to jump to 6. Now we have to jump from 9 to 99. And similarly, previously from 6 to we go previously 9. Now we have to go from 6 to new node. But this linkage you have to still missing. Let's write the code. So whatever if let's this node found node, this is the so what you say, whatever the found node we have, found node dot next dot next, what would be the next? Next would be the new node, right? Because found after that we want to add. So what would be the your? This is the new node. Correct? Second question. From 6 to previously go to the, from this is found node next, you can say found net nodes. From here you are jumping to 6 to 9. So what would be the previous of this? You can say whatever the found node dot previous must be your new node. Any doubt?
No, sir.
So so here we are just changing the relationship. We are creating one new node with deciding what is my previous, what is my next. And after that you can check the what the existing relation jumping from 9 to 6 and 6 and 6 to 9. But this relationship we have to break. We have to say now this is my 99 node, you come from here to here, and previously from here 6 to come here. So this linkage I have created here. So let's run it. Just print the both relationship. So you notice this is the 9, but where is the 12? We have do something incorrect, right? Our intention was add 99 after 9. We have added, but something we are the miss the 12. Where is my 12? 12 goes the here. Something we are doing a after new node dot next is the found node. That is the incorrect. What is happening here? In our scenario, this is the 12, this is your 9, and the 6. My new node is the 99. So what we have to say? 9 dot next should be 99. Here 9 dot next should be 99. But you have to miss
So I
what
think
was
so.
the
We have been 9 dot previous is equals to 99 dot next, something
right.
like this.
Yeah. So let's think the code what we have written. We have written something wrong. So let's again visualize. Uh, this is the 9 node, and this is your 6 node previously, right? 9 6. I want to add 99. I want to add 99. So whatever say this is the 99. What is the my okay? What is the problem here? You can say what is the previous? Previous of this previous is the 99. Okay, found node. Okay, what is the my next node? Next node. So here is a correct relationship, right? Uh, no, here why 90 come? 99 should be my previous 9. Previous 9. What is my next? Next would be my 6. So this is the 6th node. Found dot next. This is the 6th node. This is the 9 node. This is the now this is the 99 node. You make a say this is the new data. This is the found relation. This is next relation. There is a no problem till now. So problem here is the found. Okay, here found node dot next. Why I'm say previous? Yes, this is the previous. What is the previous? New node. So found node dot next. What is the next node? This. So where wisdom might say 12 dot previously they are going to the 9. 12 to 9. Just print here one thing. Just print one line here. Just check what I am getting. That's out. This is my found node. Found node dot data. Data. And what is the my next? What is my next? Next is 6. So you say found node this is equal to 6, and whatever the you created new node s out. So new node equal to plus new node dot data, new new node new node dot data 99 should be, and plus new node dot next. What is the next dot data? Okay. And similarly, what is the previous? Just print the values. Okay. So here we have created the our new node. New node the data this. This is the previous data. Previous data. This is the next data. Whatever the queue. And let's see here. Here what are changing? The problem is only this two line. Okay. Till now here whatever our logic is the correct. So here we found the now node. Okay. What is the next? Next node we found 12. Okay. Just so from head. Okay. So it's clear where we are. So here was 6, 9, 12, 2. This was our okay. We are think something incorrect. Now this is our actual linked list 6, 9, 12, 2. This is my linked list, right? Correct. And I say after 9, what we have to add 99. We found 9 node, and after what? After 12. So after 9 you can add 99. Is it correct? Our logic was correct. I am just thinking about the tail to reverse. You notice we have added 99, 9 after 99. This is my logic. Found 9 and add after 99. Is it correct?
Yes, sir, it was correct.
It was correct because we are printing from tail. So I'm confused, right? And let's just print after. That's good. Just check the reverse relation work or not. So reverse relation 2, 12, 99, 1, right? This is the reverse. So it is working like a 2, 12, 99. It's working correctly, right? Just right from here 2, 12, 99, 962. Any doubt? Is it working as per expected?
Yes, sir.
Yes. So these are the code you have to know. Is it clear? Be clear ki whatever we are doing to do in the diagram basis. Uh, Again repeat or it's okay.
Yes, sir, it's okay.
It's okay because we are just looking this data, that is the reverse data. That is the original linked list, right? Head to L. The after 9, 99 here added, right? So any doubt how you can add after node?
No, sir.
Similarly, you can do before. The logic is very simple. Now here there is no any kind of loop needed because you already, if we found node, that time you jump to the previous, jump to the next. There is no any.
And sir, we have created our new node. There we have written found node and found node dot next in. our constructor.
Mm.
So also we can do them in like
Yes, anywhere you can. Create
yes,
null null and after that set it.
yes,
But I already have a constructor and I already know whenever I am going to add any
yes,
node between these two nodes, right? Here I am going to add. So here I know what is my previous, what is my next. So already these two data already we have already found node and my next node. So why not in the constructor I pass itself? It should be clear. You can create new node. This is the new node. What is the my next? Next node is the this. What is my previous? Previous node is this. So when you already data available, you should use this constructor, right? Sometime you don't know, then you can pass null, right? In this way, your code is simple and readable. What are you doing? Just I want to kind of similar like a, let's one more logic. We are going to write logic after. Okay, before here our original linked list, right? Here, this is original linked list. I want after 99, yeah, before 99 should be at 98, right? This I want. So first you find the 99 node. This is the 99 node you found. So this is the 99 node. What is the next? Next is the 12. Next is the 12. But our logic would I want to add this new node 98 before 99, right? So what is the previous node? Previous node is 9. So whenever you found node, you have an option. You can jump to the next or you can jump to the previous. So similar logic. Now you have to place this node, so in here between this. So if this is the new node, so what is the previous? Previous would be this node. What would be the next of this node? Next node would be the this node. So whenever you are constructing 98 as a node, you already know what is my previous or what is my next. So once you maintain this link, now we have two only options. Existing relationship from here to here, here to here. Just change. Now from here, not jump here, jump to here. Previously they are jumping from here to here. Don't jump here, jump to the new node. Right? So here you can say this is the found node. What is the found previous node? You can find the previous node. Previous. Just say dot previous because doubly linked list have a both option. Now you get a previous one. And whenever you are node creating, you know what is my previous node? Previous node yeah. What is my next node? Next node is found node. And then what you say? What is the existing relation? Existing relation, this is our 99, this is our 12. Existing relationship from here, they jumping here. So don't jump here, jump to the my new node 98. So here you have to say similarly, previous existing relationship from 99, they are jumping to 12. Don't jump here, jump to the new one. So this previous node, next would be the new node. Similarly, found node, the previous would be this one. Just to change this. What is the our found node? Found node dot the previous would be the new node. What is the previous dot next would be the new node. This is the only this change the existing relation link. This create the new link. Now you can able to add. You say after 99 I want to add 98. Now not after but before. You say ki first found 99 before add 98. So this is my original list, right? Head to tail. just make one line here, something like a south head from head. Okay, from head. Okay. Similarly, it's clear. This is from head. This is from tail. Sometimes it's a so confusion. So this is our from head, right? So I want already done, right? Before 99, we can add it at 98. This is the reverse relationship, like this maintain relationship, right? This is the head to tail, and from tail to head again you reach. So whenever you are writing as small number of code, it's clear what you are doing here. But in this both method, we have not considered what happen found node is the head node, or what happen if the found node is the tail node, right? This scenario you have to handle. Here you are only assuming कि always found node would be the middle, right?
Yes.
You have to think two scenario whenever you are doing linked list. uh, what happen if your found node is the like a middle or first and last? These two scenario you mention. Let someone say कि I want add after 2 or before 6, then your head tail will be something change required, right? Those things you have to consider here before doing anything, right? So how to do it? Let's write two method. How to just add first node. I'll right now first, as usual, let add like a wide add first first node. Someone I want to add first. Okay, so how will do? As so as mentioned, first node means ki this is your first node and already linked list exists. Then what you have to do? So you create a new node. What would be the next? Next would be your existing linked list. Whatever the existing linked list, what is the previous? Previous would be my new node. After that, say it is a head, and now the new head would be this head. So here we have to do two, three things. First, create the new node, okay, and go because and just what is the next? Next would be your head. Previously had this. What is the previous of this previous node head node? What is the head of previous? Head of previous should be new head. So this is the new head. So here we have to think. First, we create new node. Okay, node, new node, and say new node. And the data part is the data. There is no any problem. What is the next? Next would be head, right? What is the previous? Previous would be null because head previous always should be null. So here you say you created one node. That node, what is the next? Next would be the head. What is the previous? Previous would be the null. But now you created new node. But new node now new node would be your head. Sorry, head would be your new node. But question is that ki head currently have a nest and also some have a previous, right? So from head node, someone go to the previous node should be your this or not. Let's think again. Whenever you create already linked list created, Okay, so they have a, this is the previous, this is the head nest already some data and previous already some data. So from here they reach to the head, right? Now you create a new node you tell ki this is the my head nest, this is the my head. But head, whatever head have, what is the previous? Now previous would be your new node. It's correct, because whatever the head, previously head pointing to the nest and previous was the null. But now in this case, this node not a become head. So this node have a two pointer nest, go to the nest, and what is the previous? Previous would be the new head. So here you have to write whatever the head previous node should be your new node, right? Is it clear why we writing here? Any doubt till now?
No, sir.
Here we need, because here we are doing two things. One, you are changing the head. This is our existing head. This was the existing head. But I want to add, first you create a new node. Yes. What is the nest? Nest would be your head. Nest would be your head. Okay. Great. Whenever someone reverse from here, they must also reach the here. So here, whatever the head what previous would be there, this node. So here say head dot previous is equal to this. And now you have maintained the nest and the previous. Both maintain here nest and previous. After that, you can say now this is not head. Now this is the head. So here say head equal to new node. That's right. Add first. Let's want to add first like 100. Let's check. We are able to maintain the relation. Now notice first your head and also from tail to reach your head. Means from previously head was 6. So 6 was previous 100. Now we are come from here, right?
Yes, sir.
Similarly, we have already last method. We can add last. There is no any problem, right? So now in this method, you have to add those scenarios, right? You will
Yes, sir.
try what happen if this node is the first node. What happen if found node is the last node? Let us assume here I say whatever the uh, last node 2, I want after 2 add something. Okay. So let us this method again after. Okay. You will getting null. Let's you say found node after 2 add a 22. See the 2 and you say add 22. So after next what would be the null? But we have not added any check here. Ki whenever you found node, what is the you are assuming ki next always value available. But here you will get a null point exception if you run, because next is a null. You are getting right?
Yes, sir.
Because our logic say here you not add, whenever you write many method, you have to ensure you are also look the corner scenario. What happen if your node is the last? What happen if your node is the first? Right? You have
Yes, sir.
write something. Okay, here you are trying to say uh yes, copy it. So what you have to think? whenever you say ki after 2, you have to check your found node is anyhow null or last node. You have to think both things. Ki the found node is a last node or is head. So how to check? Already you found the node, your data exists. The first thing always check this is something found or not. If equal to null, then what happens? You're not equal to, then and do something. At least you have to find something. And I am writing all the code. Okay, else give the message data not found, right? Else data not found. Data not found, right? Whatever data you have. So
Yes.
what happen if found? Then found you have to check the found node is last or not. So here you have to check if the our if found, then you have to check is it last node or first node. Found check it is the last node, I mean still, then what you have to do? Then what you have to do? Then you have to add node in the last. If this is the last node and you want to add after, that means you already written a function add last. Is it correct? So here you simply add last and pass the data, new data, right? It will add a last. Else, whatever you're doing, you do else. Right? Here you say if I found data, okay, the found data is 10, then add the last. And it's okay. It will add after 2 after 22. What happened if found data is a first head? Then what happened? You have to add first. Might be someone say you can add after 100, there is no problem. There is no after, there is no problem. Only in the case of next problem. If someone say add after 100, after 100 it will add, there is no problem. Only problem was the last. In the case of after, you have to take care of your tail node. So you have to check this is the tail, then add last method. Already we have created add last method. Any doubt how to handle those scenario? Because whenever you're writing method, this plain method might be not consider your corner scenario.
First and last.
Yes. So here in this case of before, let someone pass 100. Before they want to add something. Before you are getting a previous null. Someone, let's try to add up before 100. So you will getting the problem. Let someone say ki before 100 they want to add 101. So this is the 100 or head node. Whenever you run this code, it will throw exception because you are not handle the scenario what happen if the found node is 100. It will throw exception because 100 dot previous is the null. You are getting exception. So similarly, you have to write a check here. What happen if this found node, first things, this should be exist, not should be null. Someone might be write some incorrect data, okay? Might be the data not found. Then you can say data not found. Data not found. You are not doing anything, right? What happened if your found node is a head node, if if found node equal to head, then you have to, what you have to do, add first, else you do this. Just simply say add first, you already created new data. These are the some corner scenario you have to maintain while writing the code. Now it will work because someone can access your method anytime. Now you notice before 100 you can add able to 101, and you notice I am able to 100, and after I maintain the relationship from last to I reach the 101. Your any doubt?
No, sir.
Now the Balwant question is that, uh, sorry, Khushpreet, you have to add node after specific. You will try. If not, I'll guide you. Let's keep up position number 1, 2, 3, 4. This fourth place I want to add something. Right, Balwant? This is your case. So sorry, Khushpreet.
Yes, sir.
So let's you try it. If not, I'll guide you how you write. But the concept is very clear. You have to only maintain proper linkage and consider the kernel scenario. What happens if someone want to change the tail? What happens someone want to change the head? Now you will try to write these methods.
Yes, sir.
Please ask still any doubt about the what is the add first, add last, or anywhere. This is the after or before. Let's we have a handle here. If someone passed like a 110, if 110 not found, you can say data not found. At least this our method should be expected. 101 not found, right? If something
Yes,
found, then you can change, right?
yes, sir.
Your method should be somewhere fail safe, not sub throw exception. Whenever you are writing any method, please ensure it will not throw any kind of exception. Or you give proper message. If something you are not able to do, give the proper message. Yeah, something in we are not able to, your data not found, or something, right? Right?
Yes, sir.
Hmm.
Let's try it. You try method like add node after a specific position. Till now we have not done the position wise. You will try. Let's keep at the 3 position I want to add new data. At the 4th position I want to add the new data. Any position. If someone want to add the new data on the 100 position, if 100 position not found, you say position is not found, right? And you also try to write code for just like add. Similarly you can perform remove operation. Remove first, remove last, remove after, remove before, remove any specific deposition data. Okay, so let's try it tomorrow. Okay,
Yes, sir.
till
Yes,
now
sir.
any doubt?
No, sir.
No, sir.
Let's try write it code by yourself. Still any doubt, we'll discuss. Okay, this
Okay,
concept
sir.
here must be clear. Concept is very simple. You have to just change the relationship, and it you will learn it by just typing some code. Okay,
Yes, sir.
please ask if you have any doubt, because today
Okay.
tomorrow you have to write the code yourself.
Yes.
Okay, good.